if that doesn't cause any trouble, because everybody else who's presented has been between me and the screen. So I'm hoping if I stand over here, these people will be inconvenienced instead. Okay. Most of you have seen this quote before. Whenever I did something as a kid, something wasn't working, and I'd tell my grandfather, he'd say, well, you didn't hold your mouth right. Finally figured out he meant there are things that you need to do that are not obvious, and you need to learn what those things are. And that's kind of been my goal as a programmer, is to figure out what the easy way is to do things and make the computer do it for me. So the problem I'm dealing with here, we have this notion in the simulation I've been working on for many years now, Athena. I've talked about it before. We have this notion of orders. Every user input to the simulation that changes the state of the simulation is an order. It's sort of a glorified proc with a whole lot of validation code built into it. It's the basis for our undo stack. You undo orders. And every order also has a data entry dialog that goes along with it. We've got 187 orders. We need 187 data entry dialogs. They have fields that require configuration from application data. For example, you'll have pull downs with a list of valid items, and that list of valid items depends on what else you've got going on in your simulation. I'll show examples of that later. They're not static, is my point. There are complex relationships between the fields. If they don't have anything in this field, that field is disabled or doesn't even appear. Okay, that sort of thing. Or the pull down for this field, the list of valid items depends on what you've got in that field. And so you've got to update them as the user is interacting with the dialog. We'd like to have helpful and attractive layouts. I notice in a lot of the apps I use these days, the dialogues will have a fair amount of narrative text in them. It's kind of the web page view of things, so that it's easy to see what you need to do. You don't need to guess. We'd like to be able to do that. We'd like to do this in a maintainable way. It's easy to write 187 data entry dialogues that are doing absolutely everything you could possibly want. If you've got 187 people and they each get to implement one of them, and they have months to do it. You can do glorious things, but we only have 2 programmers on this task, me and Dave Hanks, who was here at the last conference. Actually, he was here the last time we were here in New Orleans as well. And we don't want to go nuts. We don't want to pull our hair out. I've lost enough of it already. We want to make it very, very easy. Here is an example. We have this notion called tactics. In our simulation, I'm not going to explain the whole thing. It's a simulation of a region in the world. The region is broken up into neighborhoods. You could think of them as more like provinces or counties, but we call them neighborhoods. There are political actors, we call them, who make decisions. I'll back up a little more. And they implement their decisions by means of tactics, as we call them. So we have a whole lot of different kinds of tactics. This is a deploy tactic. They use it if they're going to put troops into a neighborhood. This is the tactic they use to do it. And we have orders for editing tactics, and they've got to enter in all the data. So here's an example. This would belong to some actor. The actor's name isn't shown. They've chosen to deploy the Army as a group belonging to one of these actors. So that's a pull down where the list of groups, of force groups we call them, that are available for deployment for a given actor depends on the actor. If we popped this up for a different actor, there'd be a different list. They're deploying them to one or more neighborhoods. So we have a list selection field down there at the bottom. Right now they're just deploying them to the capital city. And there are a number of ways they can choose how many people they want to deploy. Right now we're saying whatever troops you got left at this point in execution, go ahead and deploy all of them. But there's other things you might want to do. You might want to deploy only some of them and give a specific number. Well, if you're going to deploy a specific number, they got to be able to enter the number in. And there's also a reinforced flag, which I won't bother explaining. But the point is, you could have any number of modes, and each of them would have specific data. And if you have enough of them, and they have enough different kinds of data, and you tried to show all of the fields on the screen at once, you're going to end up with a really great big dialogue that's going to terrify everyone who first looks at it. So the way we chose to do it was, you make the things that are irrelevant at the present time disappear. So when you've got deploy all of the group's remaining personnel, you don't see how many personnel they need to enter. It's all of them. A brief digression. We have this notion of field widgets. We defined an interface, we call it. That's a notional interface. It's a document. It's not something implemented in Tickle as such. There are a lot of widgets provided by TK, TTK, other places let you enter data. And they all have different distinct APIs. And when you're trying to write general purpose dialogue code, it's really nice if you've got a consistent API. And so we've used SNIT wrappers to get this. Every one of them has a set method. You can set the entry widget's value. You give it a string. That may be, in fact, a list of items, maybe a number of things, but there's one command to do it. You've got a get method to retrieve it. And there is a change command. Whenever the value in the field changes for any reason, the change command callback is called. That's the most especially useful one because among the various TK widgets, there's half a dozen ways, it seems like, to figure out whether the damn thing had something done to it. So now we've got just a standard way to do that. That's an interface we started using probably 5 or 6 years ago, and it's been pretty much unchanged all of that time. It just works. We got a number of types of fields now. Enums for pull downs, text, list selection, you saw that. We have a number of others that we've defined over time. Okay, my previous solution to this problem of editing dialogues, these dialogues, actually I've had 2 previous solutions at least, and you can read about them in some detail in the paper. I'm not going to go into great detail about it. But they were, in terms of layout, just 2 parallel columns. Label, field, label, field, label, field. No help text to speak of. We did have one nice thing, because we do validation from the dialogue. So we put an error message at the bottom of the dialogue. Whatever field you're in, if there was a problem in it, it shows you what the problem is down below. That was very nice. The users liked that. No other explanatory text. Dynamic configuration was extremely painful. The way it generally worked was you could specify some callbacks. And at particular events in the lifetime of the dialogue, the callback would be called. And you'd have to write a function that would say, well, what just happened, I think. You have to figure that out. I think this is what just happened. And given that, and given the current state of the dialogue and what the data values are in it, I think what I need to do is reconfigure that field, and I need to clear that. And you spend all your time second guessing what the dialogue infrastructure was doing. And that just is no way to live. You had to have a deep understanding of the dialogue code's internal behavior, and it was very hard to get right. And in fact, it was almost never gotten quite right. And you can go look at that if you like. I'm done with it now. So I came up with this notion of Dynaforms. I think it was Sean who, where is Sean? Who said on the chat this morning that the neat thing about Tickle is you can define the language you want in it. Okay? So a Dynaform, it's basically a declarative language for defining data entry forms in terms of fields. So you get fields. They correspond to a dictionary of order parameters. Every order, as they say, it's sort of a generalized proc. So its input is a dictionary of parameter names and values. And the fields correspond to those. Layout hints. How do you want this to appear on the screen? We are not just using a standard grid layout. We're not writing tickle code to lay out the fields. We're putting hints in the specification for how things should be arranged. Dynamic behavior. We're specifying the dynamic behavior in that Dynaform as well. A Dynaview is a widget that displays a Dynaform. It's got an option, Dynaform. You tell it what the name of the Dynaform is, and it displays it for you. Dynaviews supports multiple layout engines, and I'll talk more about that in a little bit, but the idea is later on we may decide we don't like the way we're laying them out now. We've got a better idea or better infrastructure to use. We can add in yet another layout engine and have the individual forms say, I want to use the new one rather than the old one, and we don't need to fix the old ones. They continue working until they're replaced. And Dynaview also adheres to that field API. So if I have an order that has a complex dict-valued order parameter type, I can use a Dynaview as a field in an order dialog. So it can be used hierarchically. And the value, since every field widget has a value you can get and set, well, for a Dynaview, the value is very naturally a tickle dictionary, field names and values. Here's an example. Take it just bit by bit. The RCC command is a layout hint. It's adding a label, and it's starting a new row and column. It's putting the label tactic ID in the first column and then starting a second column. It's for a table-based layout. And it says that it is for the tactic ID field, which is defined immediately following. Text is a command that says, here's a text field. It's called tactic ID. It's a context field. If you remember back to the dialogues I was just displaying, there was a tactic ID field at the top that was gray. That's because that field had to be provided by the application when it popped up the dialog. You get to see it, you don't get to edit it. Minus context, yes, it's a context field. And it has a load command. When you change the tactic ID, and if you could edit it, or if it's put in by the application, well, you've got to go load the data for that tactic. Okay? If this was mapping to an SQL-like database, the key changes. You got to go load the data from the database, for example. And so that load command is given the value of the field, and its job is to go acquire the relevant data and return a dictionary. The load command will be called whenever it's appropriate to call it. Your application doesn't need to think about that. All it needs to do is provide a command that, given the key, returns the data. No logic involved. You don't need to know how it's working internally at all. This is called making up for past mistakes. Next, we have the G field, which is for the group that you're going to deploy. It's an enum that makes it a pull down. You're listing a bunch of enumerated choices. And it has a list command. The list command is just like the load command in that it is going to retrieve the list of values that you want to have in your pull down. And it, again, doesn't need to know any logic. The dialog infrastructure is going to figure out when do you need to call this list command. There's an interesting thing there. You notice that the command has a variable in it, which is a very unusual thing to find in this sort of callback. Tactic ID. We evaluate that list command in a context in which all of the upstream fields, all the fields defined earlier, are available with their values as variables. So this command is returning the list of groups that are appropriate for that tactic ID, which is to say the list of groups owned by the actor whose tactic this is. And there's no complicated logic involved. We're just passing the tactic ID in. The command returns the list. Off we go. Very easy to implement. Now we get to the fun part. That mode, are you doing all of them, or are you doing some of, just some personnel? That's what I call a selector field, and that selector field is managed entirely by the Dynaform or Dynaview infrastructure. I say it's a selector called mode. It has cases, some and all. Got a symbolic name for each case, and then the text that we're going to display in the pull down. And it has a body, and that body contains a Dynaform script. Okay? So when the mode is some, you've got a personnel field and a reinforce field. When you don't have those, in this case the body's empty. You could have other stuff, but the effect is you pick deploy all, the personnel and reinforce fields go away. You pick some, they come back. And that's all handled completely by the Dynaform infrastructure. My application doesn't need to pay any attention to it at all. There's no logic code to write. It's all specified right there. And then finally, you get to pick the neighborhoods. That's an enum long list field, which is that list selection field that I showed you. And it has a dict command for its valid values. It's essentially the same as the list command used for the enum, which is the same thing. It's returning a dictionary of symbolic names and print names to display.
Do your callbacks throw exceptions, and is that what is displayed in the error?
No. Validation is handled entirely separately. As I say, these map to orders. So this is all about the user entering what's supposed to go in, get passed to the order. And as it changes, when this is being used for an order dialog, the value of the form will get sent to the order handler for validation, which will throw an error with a dictionary of field names and error messages, which will then, and a special error code, which will then be used at the bottom of the actual dialog.
So the field that depended on an actual first value, if it was a value it didn't recognize, it would just return empty or something like that?
Yeah.
Okay.
Layout engines. Right now we support 3 layout engines: end column, 2 column, and ribbon. End column is a table layout. It's the one that you've seen here already. 2 column was meant to be a very straightforward replacement for our previous code, where it's just label, field, label, field. We used that one very, very briefly when we were in transition, because it was easy to update the previous spec to that. And ribbon, where the idea was you're going to just have a bunch of things on one line that might word wrap at the end. And we've never actually used that one because it turns out you can just use an end column layout and not define any columns, and you get exactly that behavior. All of these are using TK-HTML3 to lay out the widgets, the text in the widgets. That works out very nicely. It's plenty fast and has been very pleasant to use. The Dynaform can specify which engine to use. They're all using end column by default, but you can specify explicitly, I want to use the 2 column layout for this one if you want to, or the ribbon layout. The engine is going to render all the fields, and it's going to use the relevant layout hints. Different layout engines can use different hints, and they ignore the ones that they don't understand. So I could have a Dynaform set up to work equally well as an end column layout or as a 2 column layout with all of the relevant material in it. And we can add engines or modify the existing engines if we're careful without disturbing the existing forms. So if, for example, TK-HTML3 suddenly stopped being buildable and we really had to, quick like a bunny, come up with something else to do, I could sit down and write a new engine that did not rely on that and ask for all of our stuff to use it. This is just for smiles because I had it in the paper. You know, it reads the Dynaform in, it creates a tree of all of the data that's in the Dynaform spec, and all the Dynaview is doing when it lays it out is it's just walking the tree. And when you change a mode on a selector, and I should add selectors can nest arbitrarily deeply if that's what floats your boat, it's just walking the tree and laying it out again. A couple of more brief examples. One, narrative text. We can add arbitrary labels and things in so that we can get help. So this is for a condition object that would constrain a tactic. We want the tactic to execute when the current simulation time is between start week 5 and end week 10 inclusive. So we can, it's not just label field. We can add additional help in there to make it read like something a human would want to see. Here's another one, which I'm a little embarrassed to show because what we're using it for is just dumb. But logic. There is a when statement in the Dynaform thing that can do a, you give it an expression using the values of the upstream field, using the names, just like I did in the list command. So one of the things that can happen in our model is that civilians can take casualties, and there's an order that makes civilians take casualties. And you got to specify what the group is and how many casualties they're going to take. But you know, they don't usually just go out and have casualties all on their own. There's somebody responsible. So once you specified what group is taking the damage, you can also specify who is responsible for doing it. And the design we had then, this is a very old part of the simulation, before we had that list selection field I showed you earlier, like that we were using to select however many neighborhoods. We didn't have that, and so we said you can have up to 2 responsible groups. And of course, until you picked the first one, we weren't going to let you pick the second one. And so you've got those when clauses in there. When F is in civ group names, well then we've got a civilian group to take damage. When the G1 is not empty, well then you can show them the G2. So, there you go. Our old infrastructure was very inflexible because it only worked with orders. Every order had a dialogue, and all of the code that made the order dialogues work was associated with the orders. If you wanted to do other dialogues, you were out of luck. But Dynaforms are not associated with orders. Every order has a Dynaform, but it's an independent piece of code. So we can also use ad hoc dialogues. I have a message box-like call where I can say I want to pop up a dialogue that uses this Dynaform, and it says, you know, okay or cancel, or I think there are some other options. And the user can fill out the dialogue fields, and off they go. And it returns whatever they had in the Dynaform. You can give it the default values and so on, just like you could with something simpler. So that means if we need ad hoc dialogues, it's really very, very quick to write them. I mentioned earlier we can use it as a field widget for dict-based data types. That's also been handy from time to time. So, declarative programming is a big win. I really, really like letting the computer do work for me. So I don't have to think about it anymore. Yeah, that's right. We're getting better, simpler layouts. By simpler, I mean simpler to design, simpler to implement, simpler to maintain. We've got potential for expansion and improvement. If I want to do an experimental layout engine that would do something better than what we currently have, I can put that in and live with it for a long time without breaking anything that exists. No effect on existing code to speak of. The logic is much simpler because there really isn't any. There's a few things that go in the Dynaform spec. If you need to write callbacks, they're dirt simple. They take almost no effort to write and no effort to understand, and that's not the way it was. If anybody really wants to see what we used to have to go through, I can show you offline, but let's do it before you eat. And they're not tied to the order infrastructure, so they can be generally used. We've been using them for over a year, and it's just very, very cool. I've got a few minutes, I see, and so before I take questions, let me just mirror. Here's the application. Here's a deploy tactic. I can go ahead and edit it. That's what the full dialog looks like. The part in the box is the actual Dynaform. The part in the box is the actual Dynaform. The space down here is where the error message would appear. This is an order dialog widget incorporating a Dynaview widget. You'll notice this is slightly different than what you were seeing, because what you were seeing was from an experimental version I'm currently working with. But I can say I want to deploy some. And you notice personnel is highlighted in red, and down at the bottom now it says it's a required value, and the mode is sum. So if I put in a number, well, it's okay now. If I go over here and I get rid of capital city, okay, well, so now we're deploying 123 of Group Army's personnel into the neighborhood without reinforcement. Okay? Oh, any questions? Andrew?
When I have dabbled in declarative widget arrangements, I often have found it very, very useful to have what amounts to a little way to render the specification in a little test program as part of the design process, actually trying to put the dialogue in. You know, you basically have a piece of text here, and you can say, well, gee, I kind of would like to see what this is going to look like. Did you run into the same kind of situation in your design as you develop these textual specifications? Did you find yourself also needing to see them with a little more immediate feedback, or
I just popped it up.
Okay.
Show me what it looks like.
Right.
Actually, the way I tend to develop new ones of these is I go in ahead and I write the Dynaform with all the fields that I know I'm going to need. Yeah. And the actual appearance is the absolutely last thing I do. You know, I'll make sure that if this is for an order, you know, I'll have my automated test suite testing everything that's non-GUI, and finally then I'll start working on the GUI side of it, and I'll play with it till it looks right.
Okay.
You know what the names of the widgets are? Does the programmer know what they're going to be?
No. Doesn't need to.
Or what if you wanted to add balloon help or something like that?
If you wanted to add balloon help, well, actually, let me see. I know for some of the rendering engines they do that automatically. I'm not sure if the end column one does. I'm not defining tooltips. That's something that I would have a layout hint that said what the balloon help was for this particular field. And the rendering engine would take care, the dialogue infrastructure would take care of making that happen. And I know we've got that, I think, for the ribbon and two column. I guess I just didn't implement it for end column because I was assuming we would have helpful text within the body of the dialogue instead.
Will, how many of the base TK widgets are you? I see all the obvious ones. Are there any non-obvious ones you're generating calls to?
You mean as fields?
Mm.
Or you mean within the infrastructure at all?
Yes.
Okay. We're using TK-HTML3, as I said. We're using TTK label, we're using TTK entry.
Any
So if
table.
I happen to want to render, have this drive TK in a browser, which widgets do I need to implement?
See, we do have an architecture where you can add field types externally, and we've done that. I'll be talking about gophers tomorrow, and we have a gopher field that Dynaform doesn't know anything about by default. It's something that gets added in externally.
But what I'm hearing you say is there's nothing exotic like tree widgets or anything like that.
No, nothing like that. I would, and you could, you add the external set that you want to use. It would certainly be possible to define whether you wanted to try to make Dynaview, the Dynaview widget do the job, or you rewrote Dynaview to use Dynaforms and do its own thing, would probably be the way to do it, and have a layout engine that would understand the web world.
And I might have missed you saying, are you intending to release this publicly, or is it?
I hadn't planned on it. It's kind of hard to do where I'm sitting. This code is all copyrighted by Caltech, and have to get them involved. The thing is, really, the concept is fairly straightforward.
Oh yeah, I did the first one of these declarative form things in 1983.
Yeah, well, this is my third version. The nice thing about this one is the dynamic stuff that it does. I got the callbacks right finally.
Which is not easy.
And the selector field is really very, very nice. Makes many things very easily. It would look even better on a web page than it does in a TK GUI, I think. So I think you probably could make use of something very, very similar. We may do that someday.
Is all the validation done back in the application, or is there a mechanism to say this field really has to have a user, have that validation form?
We don't, the form does not do validation. Some fields are constrained in what you can type in. For example, when we use menu boxes, you never get to type whatever you want into them. You always have to pull down. And you can only pull down what's there. But they do not actually do validation. Our field API does not include access to any of the validation mechanisms, any of the data input field support, because I've never had any luck using them. What we always do is we have an on-change command for the entire form, and whenever it changes, you get the data and you can validate it however you like. If it's an order, there's a way you call an order that just validates it without actually executing anything. Gives you back very good data about what the problems were. And so every time you type a key, every time you pull something, it gets sent to the order handler. That's worked out to be fairly robust over the years. I hate having to validate things in multiple places. I want to do it once. Okay. I really am here all week. I recommend the chicken. It was really good at lunchtime. And I'll see you again about this time tomorrow.